All right, this is section 8.2 of the notes. It's all about exponential graphs. Now, in the past, we've talked about several different parent functions. We've talked about the parabola, right, which is y equals x squared. We've talked about the line, which is y equals x. We've talked about the square root graph. Remember that one. We've talked about, let's see, 1 over x. Remember, that's one that had the two pieces to it. We've talked about y equals absolute value of x. Remember, that one looks like a v. And we talked about y equals x cubed. Well, we're going to add one today, but we're going to think about what the graph looks like. We're going to kind of develop it. Okay, so an exponential graph will look like y equals some number, I'm going to call it b for base, with an exponent of x. Okay, so the number, so the exponent is x. This other number is called the base. That's why we do b for x. So this might be y equals 3 to the x. It might be y equals 4 to the x. It might be y equals 10 to the x. So it's some number raised to the x power. That's what we're looking at. Okay, so let's start with this one. I've got y equals 3 to the x. Well, in order to think about the graph, let's pick some points and plug in. So let's say I plug in a 0 for x. Okay, if I plug that 0 in for x, I would have y equals 3 to the 0, right? But isn't that just 1? Okay, let's say I plug in a 1 for x. So if I plug in a 1 for x, I'd have 3 to the first, which is just 3. If I plug in 2 for x, I would have 3 squared, which is 9. Okay, let's go the other direction. What if I have negative numbers? So what if I put in a negative 1? If I put in a negative 1 for x, I've got 3 to the negative 1. But isn't that the same as 1 over 3? Because remember, negative exponents move to the denominator. Or what if I put in a negative 2? So that would be 3 to the negative 2. So wouldn't that be 1 over 3 squared, which is 9? And that's good enough. So what this does is it represents several ordered pairs. This first one is the ordered pair 0, 1. Then I have the ordered pair 1, 3 for my x and my y. 2, 9. This one is negative 1, 1 third. And this one is negative 2, 1 ninth. Okay, let's graph these. Well, starting at the top, I've got the point 0, 1. So that's right here on the y-axis. Then I've got the point 1, 3. And then 2, 9. So 2... I think that goes off the graph by like 1. Then I've got the point negative 1, 1 third. Let's see, 1 third is just a little less than a half, so I'll just kind of estimate it there. And then negative 2, 1 ninth. 1 ninth is tiny. I mean, it's like barely even more than 0. So I'll just put it kind of just above the x-axis. All right, so if I were to connect these dots, and I could have gone more points to the left and more points to the right, but what's going to happen is on the left side here, my graph, it just barely lies above the x-axis, and then it goes through all of these points, right? It goes through all of these points, something like that. Okay, so notice how I was telling you the graph just kind of lies above the x-axis. It's never going to actually touch the x-axis. It's just as you go to the left, it's going to get closer and closer and closer without actually touching. We call that an asymptote. Specifically, that is a horizontal asymptote. Okay, so a horizontal asymptote is like a horizontal line where the graph will come down and level off and never quite touch that line. Okay, that's called the horizontal asymptote. So in this case, because it leveled off at the x-axis, right? Isn't the x-axis, wouldn't the equation be y equals 0? So the horizontal asymptote would be y equals 0. All right, so look at the next one here. This time we're going to look at 2 to the x. So we want to think about, how do I think 2 to the x would compare to 3 to the x? Okay, well, let's pick some points. Let's say I pick, we'll start at 0 again. I'll plug in 0 for x. Well, if I plug in 0 for x, I'm going to have 2 to the 0, which is 1. hey, that's the same ordered pair that I had up above. Right? Okay. Let's say I put in a 1. So I'll have 2 to the first, which is 2. Okay, that one's not the same. What if I put in a 2 for x? So I'll have 2 to the second, so 4. Let's do one more. What if I put in a 3? So I'll have 2 to the third, that's 8. All right, let's take some negatives. What if I put in -1? Well, let's see, that would be 2 to the -1, which is 1/2. So we're getting fractions like we did last time. And let's say I put in -2. So I would have 2 to the -2. Isn't that like 1 over 2 squared? So 1/4. So the order pair there is -2, 1/4. All right, so let's look at this one. First I've got the point 0, 1 on the y-axis. 1, 2, 2, 4. Let's see, 3, 8. I think it's right there at the top. All right, and then -1, 1/2, so kind of right there in the middle. -2, I'm at 1/4, so that's a little less. So doesn't it look like this is going to graph out pretty much the same shape, where it's going to be like just barely above the x-axis, right? And then start coming through these points. Something like that. Well, if you look at those kind of together, they look pretty much like the same graph. I mean, one kind of is a little less wide, but they're still the same basic shape. Notice they both go through, they both have a y-intercept at 1, right? They both have that horizontal asymptote at y equals 0 because they level off at the x-axis. And they both kind of shoot up as you move to the right. So what happens on the graph above at the x-axis? Well, that's where we said that the graph levels off. So graph levels off. I'm going to write this down. Remember, we called that a horizontal asymptote. Horizontal asymptote. Okay. Notice in both graphs above, the y-intercept is 1, right? So whether it was 3 to the x or 2 to the x, it still went through the y-intercept of 1. Will this always be true of exponential functions of this form? Yes, but hopefully that makes sense because that 0, 1, that y-intercept came when we plugged in 0. Well, if you're putting 0 into the exponent, it doesn't matter if it's 2 to the 0, 3 to the 0, or 10 to the 0. Isn't it always going to equal 1? So that means you're always going to have the point 0, 1. So your y-intercept is going to always be 1 on any exponential graph. Okay, so let's kind of generalize. Anytime you have an exponential graph, whether it's 3 to the x, the first one we did, or 2 to the x, the second one we did, or 5 to the x, which is the next one we're going to do, or 10 to the x, any number, it doesn't matter. As far as we're concerned, it's got that basic shape. So burn that shape in your mind. In other words, it goes through the y-axis at 1, and it levels off at the x-axis, and it has that same shape. So on this one, 5 to the x, doesn't matter to me. It goes through the y-intercept of 1. Over on the left side, it kind of levels off at the x-axis, and then it shoots up. Okay? Number 4, well, that looks weird. Does it matter if it's a decimal? Not at all. If I have some number to the x, I know it has a y-intercept of 1. I know on the left side, it levels off at the x-axis, and on the right side, it shoots up. So any number to the x, any exponential graph looks like this. Well, what about if it's a fraction? So up on the top, they were all nice, neat numbers, right? Integers, 3, 2, 5, 10. Or on number 4, you're like, well, it was a decimal on that one. True, but it wasn't a fraction. It wasn't some number less than 1. So let's do some ordered pairs on this one. If I put in 0, I'm going to have 1/2 to the 0, which is still 1. Okay, so I've got the ordered pair 0, 1. So that part's not different. All right, what if I put in a 1? Well, if I have 1/2 to the first, isn't that just 1/2? Okay. What if I put in a 2? If I put in a 2, isn't that just 1/2 squared? And doesn't that 2 apply to both? So on top I have 1 squared, which is 1. On bottom I have 2 squared, which is 4. Okay, let's do some negative numbers. Let's see, that one was 2, 1/4. What if I have, let's say, -1? Well, if I have 1/2 to the -1, remember how we said a negative exponent on a fraction just flips it over? So wouldn't this just be the same as 2/1 to the first? So that ordered pair is -1, 2. What if I have -2? Well, so I would have 1/2 to the -2. Again, the negative part flips it over, so it's just like a 2/1, and then that 2/1 is being squared. Well, doesn't that just equal 4? So that's the ordered pair, -2, 4. All right, so let's put these on. I still have a y-intercept at 1. At +1, I'm at 1/2. At +2, I'm at 1/4. So it is getting closer to the x-axis, but now it's on the right side. My next point is -1, 2. And then -2, 4. Do you see what's happening? It's the same shape, but it's going the other direction, right? So it's on the right side that my graph just barely is above the x-axis, and then it comes over and it goes through those points, and then it shoots up. So still has the same y-intercept right there at 1. It's just going the other direction. Okay, notice the horizontal asymptote is still at the x-axis, so the horizontal asymptote is still at y = 0. Okay, so how is the graph from example 3, meaning the fraction, different from the previous graph? Well, it goes the other direction, right? The way I like to say it, and this may or may not make sense, that on this one, as you read the graph from left to right, it is increasing. Whereas on this one, as you read the graph from left to right, it is decreasing, right? It's going the other direction. So let's say, I'm going to say goes opposite direction. Does that make sense? If you need to write different words, then do that. Okay, so that's how the graph compares. But how does the equation, how does the equation compare? Well, we were comparing, let's say, 2 to the x as opposed to 1/2 to the x. So here we're talking about a fraction. But I'm going to say more specifically, it's going to be a fraction less than 1. So it might be 1/3 to the x. It might be 3/4 to the x. So any fraction, right, less than 1 that's raised to the x, it's the same shape, it's just going the other direction. Okay, so let's generalize here. Remember, our parent function is y equals some number to the x, and we just learned that that number might be a number more than 1, or it might be a fraction less than 1. So I'm going to say something like, if it's like a 3 to the x, that's the one, remember, that's going this, let me pull that down a second, sorry. That's the one that's going this direction. But if it's like a 1/3 to the x, right, where it's a fraction, that's the one where it's the same shape, but it's going that direction. Okay, so okay, so remember when we did transformations, I don't know, in the previous unit or so, when we would move a graph up or down or left or right. Well, if we're moving it left or right, that's going to be a horizontal shift, right? Whereas if you're moving it up or down, that would be a vertical shift. So in this case, remember the -1 is out at the end, so that means we're going to move it down 1. So down 1. The +3 is kind of like, because the 3 is with the x, it's like that's where the implied parenthesis is. So that one's going to go 3 units to the left. So left 3. And now the HA means horizontal asymptote, but let's draw the graph before we decide that. Okay, so remember 2 to the x is the basic graph, and I'm going to put that on there just so we can see it. Okay, so my basic graph, let's see, we'll do that one in green. Okay, so my basic graph, I have my y-intercept at 0, right? And it's 2 to the x, so it's essentially going this direction, right? So there's my 2 to the x graph. And then I'm going to take that graph. Now, on the other graphs, when we did transformations, that key point that we would move around was at the origin, but that's not the case on these exponential graphs. The key point that I'm going to move around is this y-intercept right here. So I'm going to take that point, I'm going to move it 3 to the left, 1, 2, 3, and at the same time I'm going to go down 1. So the point that was at the y-intercept is now moved over here. And so now I'm going to draw that same shape. So as I come out this direction, it's leveling off that 1 unit below, and then it shoots up. So hopefully that looks like the exact same shape, just moved over and down. So where my original function, my 2 to the x, had a horizontal asymptote at y equals 0 because it was leveling off at the x-axis, my new graph has a horizontal asymptote at y equal, well, hopefully you can tell, it's leveling off at -1, okay, because I moved the graph down 1. Let's look at these down here. So on number 1, I have the basic parent function, the exponential, right? 4 to the x goes through the y-axis at 1, has this basic shape, okay, and then what does that +2 do? Well, it's out at the end, so it's going to move the whole thing up 2, so that point that was the y-intercept is moved up there, still levels off kind of 1 below. So hopefully that graph looks like the exact same shape, just moved up 1. So where the original had the horizontal asymptote at y equals 0, the new one, because it was moved up 2, has the horizontal asymptote at y equals 2. And I'll give you a little hint. Notice the horizontal asymptote basically is always the number that's out at the end, right? Up here, the horizontal asymptote was -1. Let's go up here to this one. There was no plus anything out here, so think of it as like a +0. Horizontal asymptote was at 0. This one up here, there was no plus anything out at the end, so it's kind of like a +0. Notice the horizontal asymptote was at y equals 0, so that's kind of a helpful hint for you. Okay, look at number 2. All right, so we've got the basic 3 to the x. Forget the negative for just a minute. We've got the basic 3 to the x. Goes through right here at 1. It's leveling off down here, and then it shoots up, right? Okay, well, what does the negative out in front do? Well, remember before, like on a parabola, negative out in front flips it across the x-axis. Well, the same thing is true. If I flip that, imagine folding it on the x-axis. So the point that was right here at +1 is now down here at -1. But again, if you fold your paper on that x-axis, won't my graph be going this direction now? Do you see how we flipped it across the x-axis? So I'm no longer looking at this original one. I'm looking at this one that I flipped. And now from there, the only thing left is that little +1 in the exponent, which means I'm going to move my graph to the left 1. So the point that's right here at the y-intercept, I move it to the left 1. I only moved it to the left. I didn't move it up or down, so I'm not changing my horizontal asymptote. It still levels off here and then shoots down. Again, notice there's no number out here at the end, so it's kind of like a +0, and wasn't my horizontal asymptote at 0? I know it doesn't ask me for the horizontal asymptote right now, but there are some later questions that do, so I'm just trying to point it out each time. Okay, so if I look at number 3, before I do anything, can you tell what the horizontal asymptote is? Right, isn't the horizontal asymptote going to be at 1? So not that you have to, but you might even want to put kind of like a little dashed line here to show, just to help us remember, hey, that's where the horizontal asymptote is going to be. It's not necessary, but okay. So I have the basic 2 to the x graph. I'm going to see if I can save a few steps. I have the basic 2 to the x graph, which goes through right here at 1. Okay, but what am I going to do to that? I'm going to move it to the right 2 to the right, and 1 up. So now that intercept is right there. So if I draw my basic shape, remember how, I'm going to get rid of that original right there. So it levels off right here, goes through that point, and then shoots up. So having that horizontal asymptote there kind of helps you draw the graph, I think. Okay, on number 4, where's the horizontal asymptote? Hopefully you're saying at -3. So down here at -3 is my horizontal asymptote. Okay, so on this one, I'm going to draw this in. On this one, remember, yes, it goes through, it has a y-intercept, but because it's a fraction of 1/3, remember it's coming this direction, right, when it levels off. Okay, so there's my basic graph, 1/3 to the x, and then the -3 moves the whole thing down 3. So the point that was right there at 1, if I go down 3, 1, 2, 3, is now right here. And so I'm coming down, and it's going to level off at that horizontal asymptote. Okay? Number 5. Notice there's no number out at the end, so I know my horizontal asymptote is right here at 0. I'll just kind of darken it a little bit. Okay, so the basic graph goes through 1. I'm not talking the negative, I'm just talking the basic graph. Because it's a 1/2, remember that's the type that's coming this direction. Okay, so it's coming this direction. And then that negative out in front, remember, says you're going to flip it across the x-axis. So when I flip it across, the point that was at +1 is now down here at -1. So you're flipping it over, so it's kind of going the other direction, right? So it's coming up here, but it's still leveling off at 0. So I'm going to erase that green one because I want you to remember that it's the red one that is my final answer. Okay? And then on number 6, I can tell my horizontal asymptote is going to be at 2, so right in here. So no matter what direction I draw it, I know it's going to level off at that line. Okay, so remember it's a 5 to the x, so it's the original one. Let me just kind of draw it in. The original one that's going this direction. Oops. Right, something like that. Okay, so you always got to do the flip part first. So before you move it left, right, or up or down, you got to flip it. So I'm going to flip it over. Now it's going through -1, and it's heading this direction. Okay, I flipped it across the x-axis. So I'm going to get rid of that graph because I don't want to be confused by it. Now I can move it up, down, left, and right. So the +2 in the exponent moves it to the left 2. And then the +2 out at the end moves it up 2. So I'm going to go left 2, up 2. So that's my new point. You can see the direction it's going. So it's leveling off right here at that horizontal asymptote and then heading down. So again, I'm going to get rid of that green one because I want you to realize that it's the red one that's my final answer. Okay? Now, we went on and I gave, kind of a whole development of this idea of E, but I'm going to kind of give you the condensed version on this video. And basically, I'm going to come down right here to where it said the natural base. Okay, the natural base is called E. And essentially, E equals that number, that 2.718, and then it just kind of keeps going, okay? But instead of writing, y equals the 2.718, blah, 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 to the x, we would write y equals E to the x. But it's no different, really, than 2 to the x, or 3 to the x, or 5 to the x, or 2.7 to the x. But what I want you to think about is you should come to think of E much like you think of pi. Back in your Algebra 1 and geometry days, if I said, hey, what is pi? Everybody would say 3.14. And you're right. You need to become that familiar with E. If I said, what is E? You need to just be able to say, oh, it's 2.718. So it's just kind of a symbol, just like pi is. So how does that change my graph? Well, it doesn't at all. Because if E is just like 2.7, this is like saying 2.7 to the x. Well, that's just like 2 to the x, 3 to the x, anything. So it really doesn't change the graphing at all. So e to the x is the basic graph, goes through 1, coming this direction. So that's e to the x. And then what does the plus 2 do? It just moves the whole thing up 2. So now it's moved up here. Same thing is true for the horizontal asymptote. It's always that number at the end. So can you kind of picture that my graph is leveling off right here at 2? My final graph, that is. Okay, on number 2, so again, the basic e to the x is right here. So what does that negative do? It flips it across the x-axis. So it goes through now -1, and if I flip it across, now it's going this direction. All right, and then what does that +1 do? Well, it's up in the exponent, so it moves it 1 unit to the left. So my final graph, 1 unit to the left, still leveling off at 0. Okay, and then one last one. No, let's skip down to, we don't need to do that, number 3. Let's skip down to, let's go to number 6. Okay, so number 6, 1 over e means it's a fraction. So for my basic graph, it goes through 1, but because it's a fraction, it's going the other direction, right? So it's coming down and leveling off over here. Okay, so there's my basic 1 over e to the x. And then the -3 up here is going to move it 3 to the right. 3 to the right. And then this -4 right here is going to move it down 4. Okay, so I'm going to move that point 3 to the right. 1, 2, 3. And then down 4. 1, 2, 3, 4. So it's going to land right there. Okay, and you can kind of see the shape of it, but remember we said the horizontal asymptote is that number at the end. So I know my horizontal asymptote is -4. I know my graph is going to level off right here at -4. And if I draw that graph of the same shape, it's going to be coming down, go through that point, and level off right there. Again, it's the red graph that is my final answer. Okay, so your homework is on page 68 and following.